the induction motor at a very faster rate, but the major limitation of this method is the power loss is very huge at these conditions. Power loss is very high. If power loss is not a concern for you, you can go for plugging. The advantage is the deceleration or the stopping of the motor will be very fast using this. And second one, even the motor can be operated in 4-quadrant mode. So let us see how this happens. So we have already known the torque slip characteristics of an induction motor. So if I am drawing this like you have studied in this way, so if this is my value of the speed, the torque slip characteristics, the torque will vary like this. So it will reach the peak, then it will get down at speed n is equal to ns. So this is at n is equal to 0. Or this can be written in another way. This is my slip. So at this point the slip is equal to 0. At this point slip is equal to 1. So after this, if the slip is crossing this, so this is called as the braking mode. Braking mode, and this is called as the motoring mode. This is called as the motoring mode. Getting it? So if you are operating in this braking mode, it will apply the torque in the opposite direction. So then in that case we tell that the motor can decelerate at a faster rate. So now this curve also depends on the multiple things. The value of the slip corresponding to maximum torque, the slip corresponding to maximum torque will depend on the value of R2 by X2. So if you are increasing the value of the rotor resistance, then the slip corresponding to maximum torque can be changed. Even slip can be that maximum torque can be obtained even when slip is equal to 1. Let us assume if you are increasing the value of the slip, how the curve will shift. So I am just representing with some different color. Even I can make it like this. The slip corresponding to maximum torque will be here at this point. In that case, the curve will shift like this. Even I can shift it further. I can make that the slip corresponding to maximum torque will be at the time of starting. In that case, your curve will shift like this. So you can see here, as the value of the resistance is increasing, let us assume this is for resistance R3, R2 and R1. So R3 is greater than, R2 is greater than R1. So you can see here the value of under braking condition, let us assume braking happens at this speed. So the braking will be more if you are increasing the value of rotor resistance. That means we can tell the braking operation will be more effective if you are going for the wound rotor type of induction motor compared to squirrel cage induction motor. Let us first see the operation of the plugging for the case of the slip ring induction motor, squirrel cage induction motor. Let us see the plugging operation first for the case of squirrel cage induction motor. After that we will go for slip ring induction motor. So let us see how it comes and how to operate this. So I am just changing the shifting the quadrant. Let us assume this is my positive value of the torque and this is my negative value of the torque. Negative value of the torque. So now what we do, if you are taking the torque slip characteristics of a normal motor, let us assume this is varying with respect to speed, either omega or the speed. So characteristics will come like this. This is at ns. It will reach like this. So this is my operation. This is for the case of speed n is equal to 0. So these are my normal characteristics. Let us take this curve as curve number 1. So whenever you are starting your motor, so it will start from some point number G. It will travel like this. Let us assume it stabilizes at point. Some point, let us take this point as A. That means it will continue to run corresponding to the speed. So in order to apply the plugging, what we have to do, we have to change the polarity of any two phases. Because we know if you are taking your motor, the direction of this will be, let us take it as this is R phase, this is Y phase and this is B phase. So RYB is given. So then the phase sequence or the direction of the rotating magnetic field will be always from R to Y to B. Getting it? R to Y to B. So your direction of rotation will be like this. Let us assume any two phases are interchanged. Let us assume the phase Y and phase B are interchanged. That means this Y is replaced by B. This B is replaced by Y. That means you have reversed any two supply terminals. It can be even RY or RB, any two terminals. So now we know always a rotating magnetic field comes from R to Y to B. So it will rotate, start rotating in this direction. You can see here now NS is changed. That means the direction of the rotating magnetic field is now becoming opposite. When the direction of rotating magnetic field become opposite, then the characteristic also will flip. That means the positive speed now becomes a negative speed. Negative speed becomes the positive speed. That means the curve will shift to your negative speed. So this is for the case of negative speed. So let us assume this is my synchronous speed. So corresponding to this synchronous speed, your curve will come from here. So same thing I am replicating here. So the curve will shift like this. Okay, this is by reversing any of the terminals. So whenever, let us assume a motor is already running, suddenly you change the phase sequence of any two phases. When you change the phase sequence of any two phases, because the speed cannot change intermittently, so the speed is same. Here the amount of the torque that will produce will be corresponding to point number B. So because you can see that suddenly the direction of the torque is changing from positive torque to the negative torque, it become opposite torque. So this much value of the torque is applied. So this torque will be equal to your braking torque. So braking torque will be the sum of torque produced at this instant plus what is the initial, it depends on the inertia of your motor, because it is suddenly changed. So because of the inertia, it is rotating in one direction. So that also will try to oppose the direction in the opposite direction. Now what happens, it will shift from point number A to B. Now it will start accelerating in this point. It will go on moving for a stable point. It will reach the point number C where the speed will be equal to 0. Then it will start rotating in opposite direction. So up to this much, what happens, the speed goes on decreasing. Here the speed becomes 0. Now the speed becomes negative. So here the speed becomes negative. It will continue to accelerate in this point. Let us assume it will go like this. It will reach the again stable point in this direction. Let us assume that stable point is corresponding to point number T. Again this stable point, remember here, whatever is the speed here, same thing will be the speed here. It will stabilize in the opposite direction at the same speed. Now it will stabilize at point number D. So if you want to stop your motor, you have to disconnect your supply and apply the mechanical brakes when it reaches point number C. Otherwise, it will accelerate in the opposite direction. It will reach a stable point in the opposite direction. Let us assume instead of plugging, I want to use my motor operation in 4-quadrant operation. That means you need an application where the direction should change frequently. That means you have to change from positive to negative direction and again negative to positive direction, vice versa. So in that case, what we will do, again motor is operating at this stable point, again reverse the terminals. That means Y and B are again reversed. When they are reversed, again the curve will become curve number 1. Right? From this curve number 2, this becomes curve number 1. So again, this point will shift to this point. Let us take it as E. So then again, it will pass like this. It will come and reach the point number A. That means by changing the phase sequence, the direction of the motor can be changed from one mode to other mode. Intermittently for some time, it will operate in the braking mode, because here also it operates in the braking mode. During that time, heavy power loss will happen because this entire power is lost in the form of heat in the induction motor. So detailed why in plugging the amount is lost in the form of heat and other things, I have explained in the circle diagram. So you can please refer to my lecture. I will leave the link in the I tab above. You can please refer from there if you want to know why during plugging the so much heat is produced or why it is lost in the form of heat. So those things you can see there. Okay. Now I am assuming those basics are clear to you. That's why I am directly discussing here. So as our major concern is discussing about the plugging. So in the case of plugging, I am just writing the steps. So what you have to do, change the phase sequence by reversing, it is not reversing, it is by exchanging any two input terminals. Any two input terminals we can exchange or interchange. So it is not called exchange also, clear word is interchange. So by interchanging any two input terminals. Now then what you have to do, the curve will follow the path, because it will follow path B to C. So third step, what you have to, when speed approaches to 0, in that case what you have to do, you have to disconnect the supply and apply mechanical brakes to further stop it. So this is what you have to do. If you don't disconnect, what happens? It will rotate in the opposite direction. It will again come to the stable point in the opposite direction of the rotation. So this care you have to take care in the case of plugging. Now let us assume if your rotor resistance is increased, because in the case of slip ring induction motor, we can increase the resistance at the time of starting. So in that case, the curve will shift little bit. So curve will not follow this curve will follow some other curve. So let us try to represent with some blue color. So the maximum value of the torque will not change. The curve can be shifted. Let us assume I have designed my value of the rotor resistance in such a way maximum torque occurs at a slip s is equal to 1 or when speed is equal to 1. So now your curve will shift like this. So this will be my negative direction. Okay, this is my curve number 1 dash. Let us assume 1 dash. So whenever you apply the plugging, like it is passing like this, let us assume it is stabilized at some point. So corresponding to required value of the load torque, it will stabilize at some speed. Let us assume it is stabilized at some speed here, because corresponding to this is the point. So this much value of torque required for your load. So at this point is the original speed. So whenever the speed is changed, it will reverse. So when it is reversed, again this same characteristics will come in the opposite direction. So here this will be the opposite direction curve. So this is my curve. So corresponding to this point, actually it will shift from this point to this point. It will shift to this point. So you can see here the amount of braking torque now produced will be this much, will be the braking torque, new braking torque. So that is the advantage of inserting the external resistance. So corresponding to this braking torque, it will go on passing. So whenever it reaches the point C dash, we have to stop your motor. So I am just trying to draw it here so that it will be more clear to you. The characteristics are something like this. It will be, so this is my speed n, so it will be linear, and these are my initial characteristics number 1. Let us assume it is operating at some speed n, and this is my point, let us assume as A dash. So now when any two terminals are interchanged, supply terminals, then automatically the curve will become to the opposite side. So curve in the opposite side will be like this. This is my speed ns, so it will go like this. So the point A will shift to this, A dash will shift to B dash. So from this it will go on accelerating. So whenever it reaches the point C dash, we have to disconnect the supply. Otherwise what happens? It will go on accelerating. It will stabilize at a speed some n. Getting it? So this way we can do the plugging. So only major limitation of the plugging is there will be heavy power loss during the plugging. So that's why it produces so much amount of the heat. The heat dissipation should be done properly, and but the advantage is it will stop at a very faster rate. So that is the